You know, have you ever really stopped to wonder what made AI like ChatGPT possible? It feels like it just appeared out of nowhere, right? Well, a huge piece of that puzzle, maybe the most important piece, came from a single research paper back in 2017. And it had this incredibly bold title, Attention is All You Need. Today, we're going to break down this paper because it introduced a simple but absolutely revolutionary idea that completely rewired how machines understand language. Okay, so what was the big problem they were trying to solve? Well, it's this. How do you teach a computer to see a sentence not just as a list of words, but as, a web of ideas where everything is connected? We do this instantly, but for a machine, it's a ridiculously hard puzzle. Just look at a sentence like this. To get what's going on, you have to figure out what it means. Who was scared? The dog? The cat? For an AI to figure that out, it has to connect the word it all the way back to the word cat, jumping over all those words in between. That's what researchers call a long-range dependency. And for the older AI models, this was a total nightmare. Right, so before this paper, the top-of-the-line models were called recurrent neural networks, or RNNs. And they had this one major fundamental flaw. They thought in a straight line. They processed language one single word at a time, desperately trying to remember everything they just read. And this created a massive bottleneck. The model would read the, okay, got it, then dog, okay, updating its memory, then which, and with every single new word, its little memory of the sentence got murkier. By the time it reached the end of a long sentence, it had pretty much forgotten what happened at the beginning. The context just fizzled out. And the authors of the paper knew this was the problem. They put it perfectly right here. No matter how fancy you made these old models, you were always stuck with this fundamental constraint of doing things one by one. It was just too slow and way too forgetful. It was a dead end. And this is where the lightning bolt strikes. The authors proposed something totally different, a new architecture they called the transformer. The big idea? Just get rid of that whole one word at a time process. Throw it out and replace it with a mechanism that could look at every single word in the sentence all at the same time. They called it attention. So the secret sauce here is a mechanism called self-attention. And the best way to think about it is like a detective at a crime scene. Instead of reading witness statements one by one, our detective spreads all the evidence, every single word, out on a giant table. This way, they can instantly see how every piece connects to every other piece. So here's how our detective works. For every word, like chased, it starts by asking a question. That's the query. Okay, who did the chasing? Then it scans all the other words for clues. These are the keys, and it spots dog as a pretty likely suspect. Finally, it focuses on what's relevant, the values, by giving a huge attention score to dog, directly linking it to the action. And the crazy part? It does this for every word, all at once. So this self-attention thing is the heart of the whole operation. But how do you build an entire AI around it? Well, it turns out you don't just hire one detective. You build a whole squad of them. And here it is, the famous, maybe a little intimidating diagram from the paper. Don't worry about all the little boxes and wires. The only thing you really need to know is that it has two main parts. The part on the left is the encoder. Its job is to read and understand the sentence. And the part on the right is the decoder. Its job is to take that understanding and write something new, like a translation. But the authors didn't stop there. They came up with another brilliant idea called multi-head attention. I mean, why have one detective when you can have a whole team of specialists, right? That's what this is. You run multiple self-attention processes at the same time, in parallel, and each one is looking for different things. One might be a grammar expert, another a specialist in cause and effect. And this is a great way to picture it. You've got all these different detectives looking at the same set of words, but each from their own unique angle. Then they all bring their findings together. This gives the model a much, much richer and more layered understanding of the text than any single process ever could. Okay, but wait a minute. If you're looking at all the words at once, how in the world do you know what order they're in? The cat chased the dog is very different from the dog chased the cat. The model has a really clever solution for this, positional encodings. It basically sticks a little digital tag on each word that says, I'm word number 1, I'm word number 2, and so on. Problem solved. So the idea is amazing. The theory sounds solid. But the big question is, does it actually work in the real world? The authors decided to put their new transformer to the ultimate test, machine translation, one of the hardest jobs in all of AI. This was it, make or break.
And the results were, well, they were unbelievable. The old models were clunky, took forever to train, and they'd basically hit a wall. The paper claimed the transformer wasn't just a little better, it was higher quality, it was way faster to train, and because it could do everything in parallel, it was perfectly built for modern computers.
And here's the proof. Just look at the hard data. The Buse score column is what matters. It's a score for translation quality. Higher is better. You can see the basic transformer model already beats the best of the best. And look at the training cost. It's a fraction of the others. But then look at the big transformer. It doesn't just win, it completely blows the competition out of the water. That number right there, 28.4, that was an earthquake in the world of AI. You have to understand, in this field, improving a score by half a point is a huge deal. Improving it by over 2 full points, that was unheard of. The transformer didn't just break the record, it absolutely shattered it. So why did it win so decisively? Well, it all comes back to the core design. It could process everything at once, which made it super fast. It could instantly connect words from the beginning and end of a sentence, which solved that old memory problem. This all led to a new state-of-the-art in quality, at a speed no one thought was possible. We're talking trained in just 12 hours. Incredible. And even the authors themselves seemed to know they had just changed the world. You can almost feel the excitement in their conclusion. They weren't just saying, our model is good. They were saying, we've just found a key that unlocks a whole new way of doing AI. And that really brings us full circle. The paper proved that for the complex task of translation, attention was all you needed. And it left the entire research community with one giant, tantalizing question. What else might it be all you need for? And the answer, as we're all discovering now, is pretty much everything.